coordinator, Dr. Gupta. He is from the Department of Biochemistry, All Indian Institute of Medical Sciences, Guwahati, Assam. Dr. Gupta, you have 20 minutes plus 5 for the...
Thank you so much, Chairperson Professor Majumdar, for inviting me here. And at the outset, I would like to just give a comment about Professor Vinod Kumar, what he said in the beginning, that it is a fuse bulb. I would like to say this, sir, it is not a fuse bulb. You, the retired person like you, are a great inspiration for us, for this generation. And second, I would like to mention about many things Professor Anju Srivastava has made my job easy. She has already expressed many of my feelings about Professor Bharat Agrawal and Professor M.M. Chaturvedi, and I am glad that Professor Chaturvedi is also sitting here. Third, coming to my topic, as you can see, I am going to talk about how we can bridge the gap between traditional medicine and modern medicine, and through modern biology. And this aspect will be very brief. What I am going to talk about, I am going to talk about something about modern medicine. Then I am going to talk about traditional medicine, and then how we can bridge. And then I am going to talk about some molecules that I have been working in my laboratory. So having said that, so I will just take a brief introduction. This is where I come from. As of now, I am at All India Institute of Medical Sciences, Guwahati. I am heading the biochemistry department. I am also looking after the research section. And this is one of the fast growing aims in India. You will be aware that in India there are now 22 aims, and we are now taking the third batch of MBBS students, and we are also going to start MD PhD program this year. And before moving to this university, this institute, I was with Banaras Hindu University, with which I have a deep respect. But I am still affiliated with the Banaras Hindu University as I am Lian. So, and you know, I am from biochemistry department. And this is, if you talk about the modern medicine, you all will be aware, these modern medicines are also called allopathic medicine, and these are also called alternative medicine because they have been established as an alternative to the traditional medicine. These are scientifically proven and well developed after practicing on real patients, and most modern medicine that are available for cancer today, they produce several side effects, and they are unaffordable to greater than 80% of the world population. This is well known fact. Patients on modern medicine develop cancer associated symptoms such as depression, neuropathic pain, loss of appetite, lack of sleep, and fatigue. These are cancer associated symptoms. You know, when the patient develops the cancer, they die not because of the cancer, they die because of the cancer associated several symptoms. And cancer patients develop another aspect of the modern medicine is that the cancer patients develop resistance to the medicine over the course of treatment time. And you will be also aware that it takes around 12 to 15 years and almost $1.5 billion for any drug to make to the market. And most modern medicine are basically rationally designed based on mono-targeted, most specifically some specific targets. So if you talk about the potential of the traditional medicine, these medicines were basically originally believed that these are developed based on the theories, belief and experiences that are indigenous to the different cultures, and however in advances in technology over the year has provided the scientific basis for the value of these traditional medicine. And these traditional medicines are used in the maintenance of health as well as in the diagnosis, prevention and treatment of human diseases, and these have been used for many generations, and therefore these agents have well tested safety. And so approximately 80%, you will be aware that approximately 80% of the population in Africa and Asia still use traditional medicine for primary health care. And traditional medicine, it is very well known fact, these are designed multi-targeted naturally, and these can be used either alone or as an adjunct to current chemotherapeutic agents to enhance the efficacy and minimize the chemotherapy induced toxicity. And as I discussed, modern medicine, most modern medicine, they are basically designed against some specific target. And these are basically, we all know that many chronic diseases, including cancer, is basically caused by dysregulation of multiple genes. And therefore, now there is change in the paradigm. That is, we are shifting from mono-targeted to the multi-targeted agents. So this raises a question whether the process of drug development is moving in the forward direction or in the back direction. And because we are moving towards the multi-targeted agents, therefore this basically is that indicate that we are moving towards the back direction. And if you are moving in the back direction, then we need to integrate our traditional medicine into the modern medicine. And in this direction, several efforts are being taken. Here at All India Institute of Medical Sciences, we are developing one department, whole department of Ayush, and you will be aware that Department of Indian System of this Ayush was basically, there is a whole department of Ayush of the Government of India, and at AIMS also we are developing department of Ayush, and this Ayush was basically initially with the name Indian Systems of Medicine and Homeopathy, and this was renamed the Department of Ayush in 2003. And this Ayush basically stands for Ayurveda, Yoga and Naturopathy, Unani, Siddha and Homeopathy, and it is being set up in all Indians. So in the same directions, there is a Center for Integrative Medicine and Research at AIMS, New Delhi. And what is the purpose of this Ayush? The purpose of Ayush at All India Institute of Medical Sciences is to understand the feasibility and applicability of making Ayush a cost-effective and mass healthcare modality, and to develop scientifically validated holistic medicine solutions for the disease states, and to produce Ayush-specific skilled human resources, and also to develop collaborations with the clinical and research departments in AIMS to produce acceptable scientific evidence for traditional medicine system. And this purpose is also to position Ayush system of medicine as the preferred system of living and practice for attaining a healthy society. So here coming to some of the ongoing work in my laboratory. Basically, we are working on the breast cancer. We work on different aspects of the breast cancer. We try to understand the pathogenesis of the disease with respect to a class of the non-coding RNA that is called long non-coding RNA. We also try to develop some diagnostic and prognostic biomarker, basically long non-coding RNA based biomarker. And finally, we also try to develop therapeutic aspect, and here we basically focus on the natural product. And because the focus of this conference is about the nutraceuticals, I am going to talk about the third aspect, that is therapeutic aspect. So I will ask a question, why breast cancer? Because you can see the breast cancer, this is one of the top cancers, both in terms of cases and the death that has been reported. And so that is the initially cervical cancer was the first top cancer, but now the breast cancer is the top. And here are some of the popular victims of the breast cancer. You see here is the model Susan Komen. You will be aware that she was diagnosed of breast cancer at the age when she was only 13 years old, and 3 years later she died of the cancer. And to fulfill her desire, her sister Nancy Bankman is running one of the largest breast cancer foundation, this is Susan Komen Foundation in USA. And these are other popular victims. What I am trying to tell you here is that breast cancer, like other cancer type, does not discriminate between rich people and poor people. It can affect any kind of people. And if you see the predictions of breast cancer per 100,000 in 35 years in different countries, in the past years what has happened? So in developed countries like USA and Canada, there is decline in the breast cancer. But if you see the developing countries like Thailand and India, there is increase in the breast cancer incidence as well as mortality. And if you see the predictions of breast cancer mortality in the developed versus less developed countries, during the next few years, it is projected that it is going to decrease by 30% by 2030 in the more developed countries. On the other hand, in less developed countries, it is projected to increase by more than 70% by 2030, and by 2030, 85% of all cancer deaths may be occurring in low middle income countries. And the reason is here This is because of the delay in accurate diagnosis, and this is because of lack of awareness. And as we adopt Western lifestyle, that is consumption of saturated fat, calorie-dense food, and lack of physical activity, these are some of the reasons. So as you can see, considering all this, there is an urgent need to develop some novel molecule. And here I have already shown the potential of the inhibitors, potential of the molecules derived from the mother nature, that is natural products. And in our laboratory, we basically work on the one aspect of the basically chronic inflammation. And here we basically target one pro-inflammatory transcription factor that is called NF-κB. And the reason is this is because these agents are multi-targeted, and we all know that, as I explained, that breast cancer is a disease that is caused by dysregulation of not only one or two genes, it is caused by dysregulation of multiple genes. Therefore, we need something that can target multiple pathways. These are relatively well safe, so their safety has been well tested because this has been used over the years. These are inexpensive and these are relatively readily available. And according to one report, more than 70% of the drugs that are derived, that are currently in the market, they have been derived from the nature. So here I already showed in my yesterday panel discussion about the landmark of the nutraceutical research. If you see, so this is here one thing I would like to mention, that during COVID-19 pandemic period, the demand of nutraceuticals has basically increased more because of their use in immunity cancer as an enhancer of the immunity. And here is again I would like to focus, give emphasis about the importance of the nutraceuticals, about the natural products. We will be aware that our vaccine is a compound that is basically derived from the mother nature, and this is again used for the this is basically used for the treatment of and reduce the blindness and lymphatic fibrosis as well as several other parasitic diseases. And here are our own book about uses of natural products. We edited 2 books with Dr. Agrawal about the importance of the nutraceuticals and agents derived from the mother nature, that is anti-inflammatory nutraceuticals and chronic diseases, how we can use different nutraceuticals to cope up with the inflammatory conditions, and also the drug discovery from mother nature. So here in my presentation I am going to talk about a molecule that is some of you will be aware, and this is called basically piperlongumine. It is basically piper alkaloid, and what we did here is that you will be aware that doxorubicin is a molecule, is a drug that is used for the breast cancer. However, what happens that over the period of time, the patients develop resistance to the doxorubicin. So our focus was that where by taking piperlongumine, can we enhance the efficacy of doxorubicin, or can we cope up with the resistance situation? And so this work we did in breast cancer, and you will be aware that this piperlongumine is basically derived from a plant that is called piperlongum. And this piperlongum is another reason is that I come from a place that is called Assam as of now. So this plant is basically very common in Assam and Meghalaya, although it is also present in other states like West Bengal and UP also, but this is very common in Assam. So this is basically, this piperlongumine is derived from the roots of Ayurvedic plant that is called piperlongum. And if you see the discovery, this molecule was discovered way back in 1961. So the biological activity of this molecule was reported only during the last decade. The first breakthrough paper that came was 2012, and that was basically one PNAS paper. And then this activity of piperlongumine against breast cancer and the underlying mechanism is not thoroughly investigated, and this made us to work on this. Another thing is that whether this PL can enhance the sensitivity of breast cancer cells to the doxorubicin is also poorly known. So this was another reason we worked on this. So here I am going to show some of the data only because I thought I have only 15 minutes, so I will not show much data. So here is one work we did basically with the animal, and the animal we basically used was the EAC model. What we did, we took the EAC cells and we injected into the mice, and these after the 5 days we randomized the mice into these 6 different groups. One group was control, second group was PL, where we administered to the mice piperlongumine at 10 mg per kg body weight. Then we took another group where we administered doxorubicin at 1 mg per kg body weight, and then another group was piperlongumine at 20 mg per kg body weight, and then another group was doxorubicin at 2.5 mg per kg body weight, and finally there was one combination group where we administered to the mice piperlongumine 10 mg per kg body weight, followed by doxorubicin 1 mg per kg body weight, and this was basically alternate days. Means 3 days was piperlongumine and 2 days was doxorubicin. And over the period of time, over the period of 21 days, we monitor the mice for tumor development and also their behavior. And after 21 days, we stop the treatment, and then after 23 days, we examine several endpoints. At the end of the experiment, as you can see here you see the control group where only the vehicle was administered to the mice. This is the tumor size, and this is basically the piperlongumine 10 mg per kg body weight. You can see it is a little effective, and piperlongumine 20 mg per kg body weight, there is effect. And doxorubicin, you can see at 1 mg per kg body weight there was some effect. However, at 2.5 mg per kg body weight there was no effect. And when we took the combination of two molecules, that is PL10 and doxo1, then there was almost similar effect as we got with doxorubicin 2.5. So this is one observation we got. And then over the period of time when we measured the growth of the tumor, as you can see here, this is the control group, this one, and these two are basically the individual agent, the lower concentration, and at the higher concentration of the individual agent, this is the growth of the tumor, and this is the last one where you can see the combination, the tumor growth was suppressed. This is at the last day of the experiment, the tumor weight in terms of gram, and you can see this is your control group. These are the two piperlongumine 10 mg per kg body weight, doxorubicin 1 mg per kg body weight, piperlongumine 20. So what you can see here is that piperlongumine combination group, you can see that tumor weight was significantly, drastically reduced as compared to the individual agent. The next parameter we examined was about what we found was that this piperlongumine was found to improve the body weight and food intake of the tumor bearing mice. As you can see here is the body weight. When you give your piperlongumine, there is increase in the body weight of the mice, and this was basically significant. So another thing is that food intake of the mice was also improved by giving this molecule. So as I said that with cancer there are several associated symptoms like body weight is reduced, the food intake is reduced. So these are the, at least in the mice we see this, that piperlongumine can improve the body weight as well as the food intake by the mice. This is, we also examine about metabolic parameters, the metabolic parameters in tumor bearing mice, and this basically we examine cholesterol level, we examine this triglyceride level, and also we examine that glucose level. And as you can see in the serum, basically here the triglyceride level is, cholesterol level is down, and then this triglyceride level is down, but glucose level is little high. At the cellular level, we examined several parameters, and one parameter we examined was about if PL can suppress the NF-kappa B activation, that is basically induced by TNF-alpha. You will be aware that TNF-alpha is one of the well-known inducer of the NF-kappa B. And here, as you can see in the TNF-alpha alone group, what is happening that NF-kappa B, that is P65 subunit, is translocating into the nucleus if we expose the cells to the TNF-alpha. And here, piperlongumine alone is not doing anything. However, if you treated the cells with piperlongumine followed by TNF-alpha, the translocation of P65 that was happening from cytoplasm to the nucleus, that was basically suppressed if the cells were pre-treated with the piperlongumine. So this is one parameter, and we also found that by doing molecular docking studies, we found that this piperlongumine can physically interact with two subunits of NF-kappa B, that is P65 and P. So, and we also did several other computational analysis, like we examined whether this piperlongumine can physically interact with other molecules that are related with the NF-kappa B signaling pathway, like I-kappa B alpha, ITK alpha, P65, P50, TAC1, and also the GLUT1, that is basically a protein that is involved, that is basically a channel protein that is involved in the transport of glucose inside the cells. And we found that it does interact with these molecules. So another aspect that we have been working in our laboratory is about long non-coding RNAs. You will be aware that basically there are two types of non-coding RNA. One is called basically microRNA, that is well explored, and long non-coding RNA is another class of non-coding RNA that is relatively new field. And so here we are basically this long non-coding RNA we are using in other aspects also, like trying to understand some aspect of the disease and also to develop some markers with clinicians. So you will be here is basically, if you see, there are certain long non-coding RNAs that are associated with the NF-kappa B signaling, like PILAT1, and this is one project is running in my laboratory. So if you see the NF-kappa B associated link RNAs, these are associated not only in cancer, these are also involved in several other diseases like cardiac diseases, diabetes, aging, PCOS, and several other diseases. And this NF-kappa B basically, NF-kappa B and long non-coding RNAs, they basically cross them. So, and these are, when you see the long non-coding RNAs, where they are having both oncogenic and tumor suppressor function. Some long non-coding RNAs are having both oncogenic and tumor suppressor functions, as you can see here. And so here are some of our articles that we have written about the potential of long non-coding RNAs in the cancer patients, and also how we can target long non-coding RNAs by phytochemicals for cancer and other chronic diseases. Here is one of our recent book about the clinical applications of non-coding RNAs. And so here you can see, so what we have developed in our laboratory, we have developed a platform where we can examine the expression pattern of 200 long non-coding RNAs, and this is a PCR-based array. And using the same setup, what we did, we exposed the MDM-E231 cells to our molecule, that is piperlongumine, and then after 24 hours we examined the expression pattern of these long non-coding RNAs. And what we found was that one long non-coding RNA that is called Gas5, this long non-coding RNA was basically upregulated. MEG3, another long non-coding RNA, was upregulated, and on the other hand, another oncogenic long non-coding RNA, that is H19, was suppressed. So we further explored this aspect about that we use some siRNA experiments also, where we have some silenced Gas5, and then we have examined the functional assays like proliferation and viability assays, and we found that Gas5 is really involved in that this piperlongumine mediated anti-cancer activities. And here another aspect we examined about that acidosis. You will be aware that acidosis is an aspect that is basically involved in the tumor invasion and metastasis. And you can see that here what we found was that if you expose the cells under piperlongumine, that extracellular glucose was basically increased, okay, and at the same time that extracellular pH of the extracellular pH is basically of the cells is basically acidic, and that is basically because cancer cells basically heavily depend on the glucose, that is Warburg effect, and during the process they produce several lactic acid which is basically exported outside the cells, and that is again through the channel that is called, yes, okay sir, I am going to finish. So, and so here basically what I am trying to explain is that here you can see the extracellular pH was basically from acidic to alkaline conditions we found, and we found that GLUT1 and MCT4 that are basically the channels that are involved in this process, that were basically the expression of this channel was reduced by piperlongumine. So, and also for tumorigenic proteins, we found that this can modulate the several tumorigenic proteins, and data is here. So I think I will move on this data considering the time. And also we found that this piperlamine using computational analysis discusses drug-like properties. So to cut the long story short, based on this data, what I have shown and what we have found that piperlamine is basically a multi-targeted molecule, and this can basically does several things. It can basically inhibit NF-kappa signaling that will basically lead to the suppression of tumorigenesis, process of tumorigenesis. It can modulate long non-coding RNAs, and it can also induce apoptosis, and in animal models these are producing several effects, as you can see. So this is again some other molecules we are working, and I have been working on agents derived from the name, and we have found that one molecule, that is CBA, is more effective.
We need to stop.
Yes. So here I would just move on. So with this, I would like to acknowledge my group. These are my students. Some of these, the first 4 students are already completed their PhD. 3 are working. 2 are here. And I have been lucky to be surrounded by good people, both in India and abroad. And funding-wise, my laboratory is supported by these funding agencies like SARP, Indian Council of Medical Research, University Grant Commission, and Indian Council of Medical Research and Institute of Eminence. Thank you so much for your patience.
If you have any questions?
One question.
Yes, sir.
Dr. Gupta, very promising, but I heard you, and this piperlamine, whatever it is, to me it appeared to have a more global effect rather than a specific effect.
At least
So this conclusion, and that's what at the end I don't think you left anything which it does not affect. So because you measured NF-kappa signaling pathways, and I would say provocative that because you knew that this was involved in cancer. But if you would have checked other signaling pathway, I'm sure you would have found effect there as well. So I mean, what is your proposition?
my proposition, as I said, are multi-targeting. Multi-targeting is something that is required, and you are very right that it is not doing only NF-kappa B, because our focus is NF-kappa B. So we need something that is basically
I'm not questioning. I'm saying that the audience must go with an impression that here is a herb which has a multipotent, capability. So they shouldn't go with the impression that this can only be used for breast cancer. So that
no, I am not claiming that this.
No, I will not claiming. As an audience,
there are several other work that has to be done. Based on only cell line and animal work. We cannot claim that this is a potent molecule. There are several other toxicity associated work. And if you see, sir, piperlamine is really a promising molecule, and some clinical trial has also been done.
Thank you.
Dr. Gupta, one question, if you permit me.
Yes, sir.
Why does the sugar level go up following piperlamine treatment?
So basically this
Glucose,
is,
yeah.
so this is basically working through GLUT1, sir. GLUT1.
Not GLUT4.
GLUT1.
Okay.
GLUT1. And also this has effect on the MCT4. So a GLUT1 is basically the one that is involved in the transport of the glucose from outside inside the cells. And MCT4 is basically involved in the transport of the lactic acid from inside the cells to the outside the cells.
Thank you. It was a nice presentation, Dr. Gupta. Our next speaker.
I would request Professor Mazumdar to facilitate Professor Gupta for giving such a wonderful talk.